MMTk is a high-performance, language-agnostic, open-source memory management toolkit. It is able to outperform contemporary production collectors such as OpenJDK's G1. There are ports underway to Java, Ruby, Julia, Python, and Haskell runtimes. It is dual licensed under Apache 2.0 and MIT. It implements multiple GC algorithms and allows new ones to be rapidly composed. MMTk offers users the flexibility to choose from a selection of GC algorithms. Its modular design means that each algorithm is built upon highly tuned common components shared by multiple collectors and multiple runtimes. Its modular design also leads to higher confidence in the correctness of the code. Industrial runtimes with MMTk bindings can directly evaluate new ideas on their own terms, using their own in-house workloads, while researchers can rapidly develop new ideas in a flexible, credible framework. A key element of MMTk's design is its high-performance integration with runtimes. Simple integration into a runtime runs a major risk of abstraction leakage, which is prevalent in most runtimes' memory management implementations. Abstraction leakage is extremely harmful because it leads to lock-in on particular design choices. Locking into a specific approach to memory management will tie a runtime's performance to the past, preventing it from freely adapting to changes in workloads, CPUs, and memory technology. Because of this, MMTk is designed with very strong machine-checked invariants that the runtime contains no MMTk code, and the MMTk core contains no runtime-specific code. MMTk achieves performance while maintaining this rigid separation by using carefully designed per-runtime bindings. Conceptually, each binding consists of two parts. The VM interface, shown here in orange, which is the logical extension of MMTk that contains runtime-specific code, and the MM interface, shown here in white, which is a logical extension of the runtime that contains MMTk-specific code. Each runtime port must implement its own binding. An example of the VM interface is code that implements object scanning. The layout of objects and the means for introspecting them is entirely runtime specific, and yet scanning objects is one of the most performance-critical elements of garbage collection. Here we see OpenJDK's native implementation of object scanning, written in C++. In the binding, we recode that small section of performance-critical code in Rust for MMTk. This allows each of MMTk's collectors to scan objects as efficiently as OpenJDK's native collectors, while keeping the MMTk core runtime agnostic. An example of the MM interface is the implementation of a write barrier. A write barrier is a small piece of code used by many garbage collectors to track writes to pointer fields, in order to facilitate more efficient collection. Write barrier code is implemented by the runtime's interpreter or its JIT compiler. Here we see the code that implements one of MMTk's barriers in OpenJDK's interpreter. Here we see the code for OpenJDK's C1 compiler, and here the C2 compiler. By putting this code in the binding, we are able to keep OpenJDK free from MMTk code while still being able to implement MMTk's semantics as efficiently as OpenJDK's native collectors. You can explore and contribute to MMTk via GitHub and by joining our Zulip channel. Our status, as at the second quarter of 2023, is that we have ports underway to 6 runtimes. The OpenJDK port is reaching the point now where it can pass large test suites and run large production workloads competitively with OpenJDK's native collectors. In 2022, we published a paper that demonstrated that LXR, a new collector built in MMTk, was able to outperform OpenJDK's G1 collector in terms of throughput and user-observed latency on the Da Capo benchmarks. The MMTk team gratefully acknowledges the substantial contributions of many individuals and sponsors. We are actively sponsored by Shopify, Relational AI, Google, and the Australian Research Council. If you're interested in MMTk, please reach out to us. We're looking forward to working with you.